Welcome to Understanding Algebraic Expressions. Now this is grade 8 work, but I welcome all high school students who are just not understanding algebra to join me in today's lessons to cover the fundamentals and the basics that you may actually just be missing to finally make algebra click. So join me in today's lesson on Understanding Algebraic Expressions. Algebra involves the use of letters in place of quantities and numbers. A term is separated by addition and subtraction signs. How many terms are here in total? 2 terms. They are separated by addition and subtraction signs. Let's now talk parts of an algebraic fraction. Variables are the letters in our expression. So over here, m and x are the 2 variables in this expression. Coefficients. Coefficients are the numbers in front of the variables, the letters. So the coefficient of m is 5, positive 5, and the coefficient of x is negative 4. Many students make the mistake of not putting the sign. Please put that sign. If you just write that the coefficient of x is 4, that is incorrect. The coefficient of x is negative 4. Then the last part of our expression is called the constant term. The constant term is the number. So negative 9 is your constant term. Constant, meaning it is negative 9. It will not change depending on what the variable's value is. Now you try. First, let's look at how many terms are in this expression. We've got 1, 2, 3, because it's in brackets, 1 term. 4. So we have 4 terms in this algebraic expression. Now I want you to identify the variables in this expression. P, Q, R, and W. Those are all the variables in this expression. What is the coefficient of P? Positive 2/7. What is the coefficient of Q? Positive 4. What is the coefficient of R? 1. The coefficient of W? Negative 1. And lastly, identify the constant term. 18. Positive 18. Let's simplify this algebraic expression. The first thing you want to identify are the like bases. So like bases means that the variable and the exponent of the variable is exactly the same. So we've got 3x and there we've got another x. So the 3x and the 6x can work together. Then we see we've got an x squared and another x squared, and those can work with each other. Okay. Remember to look at the signs you are working with. So let's just rearrange this so that you can see who's working with who. 3x plus 6x minus 2x squared plus 10x squared. Now let's work with the 3x and the 6x first. 3 plus 6 is 9. 9x. Let's go work with the x squared next. Minus 2x squared plus 10x squared. Minus 2 plus 10 is plus 8x squared. Remember, that's basically saying 10 minus 2, which is 8. And this is my final answer. I cannot go any further than that. Simple, right? Now I want you to try. First thing we're checking are the like bases. AB squared, AB squared. A squared B, A squared B. Minus 4, minus 7, minus 11AB squared. Plus 2, plus 5, plus 7A squared B. And that's my answer. Let's try another one. Remember to identify those like bases. 4p squared minus 3p squared minus q minus q. 4 minus 3 is equal to p squared. minus q minus 2q. Q has a little 1 in front of it, so it's minus 1 minus 2 is minus 3q. Then r is on its own, so we just leave it as minus 6r. Then finally we add our numbers. 5 plus 8 is 13. I've got more practice in the description below. Now for multiplication of algebra using the distributive law. What this just says that this variable on the outside is distributed to everyone inside the brackets, meaning that A is multiplying by B and A is multiplying by C. So we should get this answer, AB plus AC. Simplify the following. 6y multiplied by 3 is equal to 6 times 3 is 18y. 5x cubed multiplied by negative 2x to the 7. My numbers, 5 multiplied by negative 2 is equal to negative 10. When I multiply like bases, what do I do to the exponents? We add them. So x3 plus 7 is 10. Now you try. 4 multiplies into 3a and to 2b. So my answer is 12a plus 8b. The same thing happens for our next expression. P cubed multiplies to every term in the brackets. There are 3 terms. P cubed multiplies with 7p cubed, with minus 4, and with positive 2. Making it equal to 7 p's. When I multiply like bases, what do I do with the exponents? I add them. So p to the 1 plus the 3 gives me p to the 4. Then q minus 4 p q. When I multiply like bases, what do I do with the exponents? I add them. So q1 plus 2 is q3 plus 2. Remember the number out here is a 1, so we're multiplying with that 1 the whole time. P1 and P1 gives me P2. Q1 and a Q1 gives me Q2. Now let's get into division of algebraic expressions. So when we see a fraction like this, it also means this. Let's simplify these two together. First, I have a look at my coefficients, my numbers, 18 and 12. Now, what can divide both into 18 and 12? 6. 6 can go into 18 3 times and into 12 twice. When I divide like bases, what do I do with my exponents? I subtract them. So I'm going to say 3. Where's my biggest exponent? At the top. So I'm going to move that 7 to the top. So it's going to be x 9 minus 7 over 2. Finally, making my answer equal 3x squared over 2. Right, we can see we've got 2 terms in our numerator. So I first want you to write the fraction out like this. 6m over 7 over the denominator 2m to the 4 minus 8m to the 5 over the same denominator 2m to the 4. Now let's work with it. I can see that 6 and 2 can divide into each other. 2 can go into 6 3 times and into 2 once. Then when I divide like bases, what do I do with my exponents? I subtract them, and I always go to my bigger exponent. So we're going to get 3m. 7 minus 4 is 3 minus 8 divided by 2 is 4. Okay, 2 can go into 8 4 times and into 2 once. Then when I divide like bases, I subtract my exponents, and I always go to the bigger exponent, which is at the top. Then it's 4m. 5 minus 4 is 1. You can just write it like that. And there's our answer. All right, we've almost gone over it all. Squares and cubes. Any exponent that's a 2 is a square, and an exponent that's a 3 is a cube. So I want you to remember law 3 of our exponential laws. that says that when our exponent is directly outside of the bracket, it multiplies in. So a to the power of 3 squared is equal to a to the power of 6, 3 times 2. Then a to the power of 3 cubed is equal to a to the power of 9, 3 times 3. Now, let's go over some roots. Now we've got a square root that's got a 2 on the outside of our root and a cube root that's got a 3 outside of our root. Let's start off with a square root. What this is telling us, that this number on the outside of our root is going to divide with the numbers in our exponents. So, for instance, this answer is going to be a to the power of 2 divided by 2 and b to the power of 4 divided by 2. So our final answer is equal to a to the power of 1 and b to the power of 2. So ab squared. Now, let's look at our cube root. Over here, remember our rule says that we divide with the number outside of that root. So I'm going to go a to the power of 6 divided by 3 and b 3 to the power of 3 divided by 3, which gives me a squared b to the power of 1. And that's my answer. Determine the following. Minus 5k to the 3 squared. Remember that this exponent 2 is going to go to that negative 5's exponent of 1 and to the 3, the exponent of k. So how I write that down is negative 5 to the power of 2 multiplied by k, and 3 times 2 is 6. So my final answer is going to be negative 5 times negative 5 is a positive 25k to the 6. Our next one, the exact same thing happens. Law 3, we are multiplying it into the bracket to every one of our exponents. It applies to everyone. So then our answer would be 2 to the power of 3, x to the power of 5 times 3, 15, and y to the power of 4 times 3 is 12. And that would give me 8, x to the 15, and y to the 12. Let's go over to our roots. C, 36a to the 12. Okay, we work with our coefficient first, our numbers. What is the square root of 36? It is going to be 6. Then what did we say we do with these exponents? We divide it with that number outside. So this number over there is a 2. So then it's 12. A to the power of 12 divided by 2 is 6. Let's work with our cube root here. We first look underneath our cube roots and we see that these terms are adding. We can only add and subtract like bases when the variables and the exponents are identical. We have a look, x to the power of 9 and x to the power of 9. They are like bases, so we can add them together now. So 12 plus 15 is going to equal to 27. So 27x to the power of 9. Now we can go work with our cube root because we've got one term underneath. What is the cube root of 27? 3. What did we say we do when we've got our variable and an exponent? We divide with roots. So x to the power of 9 divided by 3 is x to the power of 3. There you've got it. If this lesson was helpful, please support me by liking, subscribing, and sharing my channel and this video. You are going to want these notes and extra practice in the link in my description below. Happy learning, and remember, you got this. I'll see you next week.